All right. So we are going to continue talking about Chapter 2. A couple announcements. Your lecture outlines are uploaded. Have you guys seen this or no, not yet? It should be on eCampus, so take a look. If you can't find it, let me know. And also, last time I checked yesterday, no one dropped the class. So you're stuck with me now, whether you like it or not. I hope you stick to the end. Great. And I hope you success in this class. Okay, so make sure you put your attendance on Google Doc. I need to submit the attendance certificate to the university. It's a university rule. If I see that you haven't been attended, I will mark absent on Howdy, which might affect your scholarship, or I don't know what it will affect, but it's a school requirement. So make sure you put your attendance on Google Doc. Okay, so last time we talked about psychology is not common sense, and we talked about people prefer those who are similar, right? So now let's do another question. It worked.
It worked?
Yeah, sorry about that.
Okay, cool.
Thanks. So true or false, you are born with all the brain cells that you ever have. If you think this is true statement, raise your hand. Okay, 2. If you think it's false, raise your hand. Okay, I'll allow you. Have you heard of this statements before?
No.
You haven't? Okay. So it was a pretty common view when I was in undergrad. So that was like 4 or 5 years ago. Okay, great. So it means that the knowledge has been updated. This is false. Your brain cells continue to generate as you grow. However, it doesn't mean that you should kill your brain cells. You shouldn't drink too much until you black out. That kills your brain cells. Stay up too late. That kills your brain cells. So don't do that, even though they regenerate. Okay. So last time we talked about the scientific method, the 5 steps. I think we went to step 3. So now, say it again?
Yeah.
Okay, cool. So we are going to finish the scientific method today. And we are going to talk about descriptive research as well, if we have time. Okay, so remember, the first step is to observe a phenomenon, to find something that you're interested in. And then the second step is to predict. So after we know the variables and operationalization, how to measure those variables, we need to make a hypothesis, right? So those are educated predictions. So we need to make a hypothesis based on what we have observed. The hypothesis, they need to be very specific, and they need to be testable or falsifiable. Do you guys know what this means?
Wrong.
Yes?
You need to be able to prove it wrong or argue against it.
Okay, very good. So testable, you need to be able to prove it, right? So let's say okay, this might be a little political, but just an example. So let's say someone say that abortion is evil. Is this a hypothesis?
No.
No, because you can't test it, right? Whether evil or not is more subjective, right? Okay. Now, can you think of an example of a hypothesis that's testable? Yes.
An if-then statement?
Okay. So if I say that if someone does abortion, then that's evil. Is that a hypothesis?
Yes. Well, no.
Okay, so it has to be more specific, right?
Yeah.
Okay, can you think of any example? Yes.
Like, how long can a plant last in a certain amount of like heat? Maybe that would be a good hypothesis.
That would be a research question, right? So hypothesis, it has to be kind of like what you just said, if then. It's like under certain situation, something will happen. You're making a prediction. Yes.
If you stay up too late, you will lose brain cells.
Yes, very good. So, and you can test that, right? If you have the right equipment. Yep, very good, very good. I'll take one more. Hypothesis that you think is specific and testable or falsifiable. Yes.
So I know last year when they were starting or saying about predicting where Corona would go, they said when it got colder or when it got hotter out, it would kill it more.
Mhm.
So would that be a hypothesis?
Yes. So that would be a hypothesis. Very good. So we can test that, right? We can see the results. Okay, I'm trying to remember names. Ethan, Louise, Nicholas, Claire, Cameron. Okay, cool. All right. I didn't miss anyone, right? Okay, good. Did I? Okay, sorry. Okay, so theories. Sometimes we use hypothesis and theories interchangeably, right? But they're different, at least in scientific fields. Especially in psychology, theories is very different from hypothesis. So theories, they are tested through research and experiments. They're based on evidence, and they often are used to generate new hypotheses. Does that make sense? Difference? So theories is something that we are pretty sure exists or it's correct. Can someone think of a theory that has been proved throughout time or research? Yes?
Humans are made of cells.
Okay, very good. Ella? Ella, okay. Ethan?
Gravity is technically a theory, but a very well proven one.
Yeah, yep. Anyone? Luis?
An object. Proof. Every force has an opposite or equal reaction. That's a theory.
Okay, so it's more about physics?
Yeah, but it's
Okay.
still theory.
Yeah.
Physics.
I'm just asking like which major is it? I'm not very
Physics,
familiar
yeah.
with it. Okay. All right. Cameron?
What is it called? I think it's called the heliocentric theory, but about when they were the sun, how everything revolves around the sun as opposed to the Earth.
Oh, gotcha. Yeah. All right. I'll take one more. One theory. Anyone from this side? No? Kyle? Carter, I'm sorry. Carter, okay.
The Earth is round.
Say it again?
The Earth is round.
The Earth is round? Okay. Kyrie Irving would disagree with you, but very good. Do you guys watch basketball? Okay, so you know Kyrie Irving is a flat earther, right? Okay. Well, if you didn't get it, that's fine. Okay, very good. So know the difference between hypothesis and theories. Next, we need to test our hypothesis, okay? And do you remember validity and reliability?
Yes.
Okay, can someone explain validity and another person explain reliability to me? I'm trying to find new voices. Nikki and then Lilia? Haley, okay. Okay, Nikki, you go first. Oh, sorry. What's your name? Andrea. I'm sorry. I think it's because the seats keep changing, so I'm sorry. All right, I'm still trying to remember names. Andrea? Andrea. Okay, go ahead.
So reliability is like something that you're testing with, like, you know, it's gonna work every time that you're gonna get like an accurate answer. Not necessarily the answer you want, but like, you know, accurate.
Wait, so are you saying you get the result and you know?
Like if you go on a scale and someone that you know for a fact is like 30, whatever, then you're gonna get like something around 30.
Okay, so reliability is more of you getting the same results over trials.
Yeah.
Okay, is that what you mean? Okay, very good. So throughout time, throughout trials, you get similar or same results. That's reliable. Okay, and then your name again?
Haley.
Haley. Okay.
Validity is like the test is actually measuring the variable interest.
Okay. Can you give me an example?
Like if it's a low validity, it means like the conclusions are inaccurate.
Uh-huh.
And if it's high, it means like the conclusions are accurate.
Okay. Do you have an example of a valid measure?
Not off the top of my head, no.
Okay. What will be the example that we used in last class?
Target.
Oh yeah, the targets.
Target?
Target.
Do you mean the pictures?
Yeah.
That's just an illustration. What would be like an actual example in life? Yes, Ethan.
One of them was a valid measurement of weight would be using a scale versus using like a tape measure.
Very good. So using scale to measure weight, that would be a valid measure. And asking psychology questions on a psychology exam, that's a valid measure, right? Very good. Okay, so reliability, the test or measure gives us a consistent results over time or trials. And then validity is the test is really measuring the variable that we're interested in and not something else. Very good. So make sure you understand what they mean, and then you can find examples in life to apply them. All right, next we have interpret. So after we have our hypothesis, we need to test them. We need to analyze and interpret the results, right? So we need to use mathematical techniques. Who's a psychology major here? No one? Okay, great. So when I changed my major into psychology, I thought there won't be any math because I hated math. It turns out we still have to use math, which is pretty disappointing to me. But if you decide to major in psychology, know that there's math involved. We use a technique called statistics, which is like a branch of math, to analyze data and interpret results. Okay. Let me take a look. Online students. Psychology major. Okay, we have psychology minor. Okay, cool. So not many people are psychology major here. Okay, and then the fifth step is to communicate our findings. After we tested a hypothesis, after we interpreted the results, we need to communicate it. So usually in the field of psychology, we publish our findings in a scientific journals. In my opinion, it's not very efficient because journal articles are so expensive. I don't know if you guys know that. If you are not affiliated with the the university, you can't get access to those journal articles for free. Usually, one article costs about $30 to $50, which is crazy to me. And then we have class. We teach students about the findings that we found in research. So what else? what can you think of? The ways that we communicate a research finding. Yes, Ethan.
Well, I think I read about this with, it was in like one of the chapter reading just with news a lot of the times, like to look at different statistics that have been posted. They aren't always super accurate because
Mhm.
they can be not fully completed studies. There's the problem with recreating studies and stuff like that. But news sources that we all see usually will state some sort of statistics, whether or not they're accurate.
Okay, so that was a lot of information. So first you said that you get the information from the news.
Yeah.
Okay, and then you said that recently there are a lot of findings they can't replicate. Is that what you said?
It was like one of the chapters that we read, I think it may have been like chapter 2, but it was this, like, sometimes studies that are talked about in the news aren't always reproducible. And like things in scientific journals are kind of only like 50% of them are really reproducible when it came to psychology.
Yeah, very good. How many of you remember that part of the chapter? Okay, great. So that's called replication crisis in a lot of the fields. And my dissertation is actually a meta-analysis on that. If you're interested, we are going to talk about that in our next class. Very good. So news. Just know that in the news, a lot of times they're not scientists, so they can interpret the results incorrectly. There are a lot of examples. I'm trying to think of something right now, but I can't really remember. So have you heard those crazy theories like eating chocolates actually make you lose weight, or and then something crazy that's like very eye-catching stuff on the magazine or on newspapers? Is that they interpreted the result incorrectly. Is that they might find some participants lost weight after eating the chocolate, but it's not for everyone. And then they just use that piece of evidence and then try to make a story out of it. So that's what happens in a lot of the news and media. So pay attention and be careful what you see on news, especially Facebook or YouTube. They have a lot of pseudoscience on the platform. Okay, what else? We have conferences. We do this pretty much every year in different fields. Researchers or professors, they go to conferences to give a talk or present their posters. We have TED Talk, right? Usually TED Talk is pretty reliable and credible, but sometimes TED Talks can be a little iffy too. I heard that you can pay to give a TED Talk. So, yep, just have critical thinking whenever you are receiving any information online. Who knows this person? Her name is Amy something? I forgot. How many of you heard of PowerPost?
PowerPost.
Yes.
That's where you like say confidently with the children that giving just more confidence and feel more powerful basically.
Yes, very good. What's your name?
Maya.
Maya? Okay, very good. So according to her, I think she's from Harvard, she did this study, is that people hate public speaking, right? How many of you don't like public speaking? A lot of you. So her suggestion is that before you give a speech, you go to a restroom, have a mirror, and then do power pose like this, and then Superman pose, and it will boost your confidence. So that was a pretty cool finding, but right now we find that it's hard to replicate. But still, that's a part of science. Like, we need to test and retest and see whether the findings are correct or not. All right, and we have TV shows. Sometimes we see scientific findings through TV shows. Have you seen the show called Lie to Me? Yeah, that one, it's pretty accurate. It's it's talking about facial expression, right? Facial expression? Yeah, micro facial expression, and see how that, if people lie to you or not. So it's a pretty cool show. I think it's an old show, but you can watch it if you're interested. All right, any questions on the scientific steps, the 5 steps that we talked about? We good? Okay. Okay. Next, let's talk about descriptive research. Hold on, let me make sure if online students are caught up. Okay. Good. Okay, so for descriptive research, the goals are to define a problem and variable of interest. And then we are trying to describe behavior and mental process through descriptive research. Okay. However, descriptive research or descriptive studies, they make no prediction. They don't have any control or manipulation in the study. So remember, we have variables and how to measure them, right? Usually we need to manipulate them as well in the experiment, but in a descriptive research, we don't need to manipulate a variable. And then this is more for exploratory purposes. So usually before we conduct a real experiment, many people would do descriptive research first to gather more information. Okay. Any questions? Yes?
What do you mean, like, they don't control or manipulate variables? Like, are they just observing someone?
Kind of. Yeah, I'll give you some more specific examples. When I say no control or manipulation is, so let's say if I control the lighting here, I'm controlling or manipulating this variable, the lighting of the room, right? But in a descriptive research, I'll just let it to be its natural setting. I don't control anything. Does that make sense? All right, great. Very good, very good. Okay, so we have some methods in descriptive research, including naturalistic observations, case study, survey, and correlational study. We'll talk about this one by one, so don't worry if you don't have them down right now. So for naturalistic observation, those are observations of behavior in the environment in which it typically occurs. What's her name? Jane Goodall? Yeah. So that's a very typical example of naturalistic observation. Let me ask you a question. When you do this, should you participate or should you just observe? So it's just like kind of participating in the chimp's life, right? Sometimes psychologists or sociologists, they have this debate is when you observe a group of people or a group of animal, do you need to be part of their life or you should just be an observer on the side? What do you guys think? Yes?
I feel like it kind of depends because in some cases it's hard to be able to observe their full behaviors because a lot of people are closed off to outside people.
Mhm.
Like another thing the textbook said that like these psychologists had to infiltrate a cult by pretending to be members of it in order to gain psychological insight on that.
Okay.
But I think for the most part that can negatively impact the validity of your results because it's adding in a new thing that's not typically in that environment.
Very good. So would you say preferably we want to just observe and not intervene?
Yeah.
Okay, but if the environment does not allow you to just observe, you kind of have to participate. Okay. Do you guys agree? Okay, great. Yeah, that's what I thought too. Okay, very good. So the strength for naturalistic observation is that you are in a realistic setting, so people tend to behave naturally in a realistic setting. Can you think of some limitations of naturalistic observation. I'll give you about 1 to 2 minutes to talk about this, and then I'll take some volunteer.
And so I guess I feel like something that you need that research to know, because if people like what we're doing,
It'd be time consuming.
like unconsciously.
Maybe like,
But I think it just depends. You know.
it wouldn't be. Time, the time limitations.
All right. I am going to take some volunteers. Anyone? Yep.
Like one of the limitations could be that like there's some areas like if you're just observing or like even participating, there's sometimes areas that you can't like go into, like someone's house. If you're not participating, you're stuck outside observing them, and if they go like somewhere private, like their house, you can't really
Mhm.
observe them there
Mhm.
unless you participate. But yeah.
Okay.
So, you know what I
Yeah.
mean?
So sometimes you can get some information that you want. Yep. Okay. Very good.
I would say like with this particular example, like with animals in general, some of them are just too dangerous to really get that close to.
Mhm.
So you can't
Yeah.
really kind of limited access.
Yeah. Yeah. Like can be dangerous, right? Yes.
Well, there is some things you can observe, like if you wanted to observe anger and nobody's angry,
Mm.
you can't manipulate that at all.
Mm-hmm.
Then like there's no way you can observe anger in those people.
Yeah, so this kind of ties to what the student says here, like time consuming. Sometimes you have to wait until the situation occurs. Okay, very good, very good. Okay, those are very good points. So one limitation is you can only describe. You cannot tell what the cause or the effects are based on what you observed. You can only describe that behavior. And then you cannot look into private or rare events, like what Louise said. So let's say in psychology, some people are interested in sexual behavior. You can't just hide somewhere and then observe people and study their behavior, right? So that will be unethical and illegal. We cannot do that. We have self-awareness and then demand characteristics. So if people know that you're observing, they will behave differently, right? Usually, if we observe someone and then and the participants knows that, they will tend to behave in a way that they think is desirable by the society. Does that make sense? Okay. Also, people tend to work faster when they know that they're being observed. This has happened in factories, in schools. If they know there's a camera or people are watching, their supervisor are watching them, they tend to work faster. It's pretty intuitive, right? Okay, very good. And then we have observer bias and the double-blind research method. So observer bias is being the researcher. I have my own bias coming in. So if I have a hypothesis before I'm observing a behavior, I tend to look for those traits. And it will be more likely to confirm my hypothesis. That will be my bias. Does that make sense? That's also called confirmation bias. It is when you know an idea and then you look for evidence to support your idea. Does that make sense? We'll talk about that more in future classes. Okay, double blind is to kind of get rid of that, so the researchers, they don't know what they're looking at, and the participants, they don't know what conditions they are in. So that's a better method to do this. And poor or no control, so we don't have controls, we talked about. All right, any questions on naturalistic observation? Good? Next, we have case studies. They are intensive examinations of a specific person or situation. So the strength for this type of study is that it's very detailed, and you can study rare and private phenomena. You can ask them for permission, and then you can get a lot more details by doing case studies. What are some of the limitations for case studies? I'll give you about 1 minute to talk about it. Then we will discuss this.
The people like taking notes could just specifically put stuff in the report. Yeah, you're right. God, I'm so tired. I regret eating nothing. It's such a good fun.
All right, so case studies. What are some of the limitations for case studies? Yes.
You can't like repeat the results, but it's just like a one-time.
Okay, so you can't repeat, or it's very difficult to repeat if it's a rare case. Yes, very good. What's your name?
Lane.
Lane? Okay, cool. All right, very good. Cannot repeat, or it's very difficult to repeat. Yes.
And also just the possibility of the results that you find not being replicable because you're only examining one person and their individual differences that can just make it so that the results you find aren't really important.
Okay, very good. So you might only apply to that one person or that one case. Very good. Yes.
Similar to that is that like whoever you're studying, they could always just like lie or like fake like something.
Mm-hmm. So if it's like an interview, they could fake the information. So okay, very good, very good. So the main problem that we think for case studies is that they may not be representative. So it might not apply to the general public. Okay. Do you guys know this person?
Nope.
Dennis Gage. Okay, I'm gonna show you a video about him. It's pretty interesting. Computer is loading. Oh, come on. May I have to complain. Our school, they have the worst computers. Like, you can't even run a PowerPoint. Problems that. Oh, come on. All right. So you will have millions of dollars to build hotels, football fields, hire a coach, and we don't have money for freaking research. Like my computer in my office, freaking 8 years old, and they said that they got a new computer for me. Like, come on. All right. Let's see. Okay. Well, that's my bias because I'm not into football, sports. So I think, and I'm a grad student, so my bias is towards science. Spend more money on research. Hold on. Of course, if you're a sports fan, you love it, right? Got huge stadiums. All right, let's see if it works this time. please?
Hello, everyone.
Oh,
One
nice.
of the most famous figures in neuroscience, biology, and psychology is Phineas Gage. His story
What? Wow.
gave researchers insight into how cognitive functions are localized in various areas of the brain. That is, that different parts of the brain control different parts of our behavior. It all started in Vermont on September 13, 1848, when Phineas Gage, a railroad foreman, was in the process of blasting some rock during railroad construction. In order to do this, he drilled a hole and filled it with gunpowder. Typically, the next step in this process would be to put some sand in the hole so the gunpowder blasts the rock safely when you slam the iron rod in it. However, for unknown reasons, Phineas did not complete that step, and a spark from the iron rod hitting the bottom of the hole ignited the gunpowder. This launched the rod into his skull from under his cheekbone, behind his eye, out the top of his head. This damaged his left frontal lobe and knocked him off his feet. Surprisingly, Phineas never lost consciousness and actually walked to a carriage that proceeded to take him to the hospital. For the entire mile-long journey, Phineas was completely conscious, talking, and even sat upright. When he arrived at the hospital, he famously said to John Harlow, the doctor who saw him, "Here's business enough for you," and he wasn't joking. Basically, with the amount of destruction in his head, it's miraculous Phineas didn't die. Gage did get an infection a few days after he arrived at the hospital, which led him to fall into a coma. He also lost all vision in his left eye. Several weeks later, though, he returned to his home and brought the iron rod with him. When he returned back to work, his friends noted that he was no longer Gage. Whereas before he was calm, smart, professional, Gage was now moody, profane, violent, and uncontrollable. Due to this change in behavior, Gage lost his job as a railroad foreman. Not much is known about Gage's whereabouts after this point, but there are stories that he displayed himself, his head, and the rod all across Northeast America. He was like a traveling show. In 1852, he traveled to Chile, where he found work driving coaches during the country's gold rush. Some researchers believe that the fact that he found a job driving coaches meant that his brain healed in some way, given how cognitively demanding stagecoach driving is. He would have had to take care of the horses, collect fare, steer in the right direction on crowded streets, and so on. This is a lot to ask from a man who was previously described as uncontrollable and violent. In support of this claim, one doctor who lived in Chile noted that Gage was in the enjoyment of good health, with no impairment whatever of his mental faculties. While Phineas almost certainly did not recover completely, one can assume, based on the complexity of his job, that he made meaningful progress in his cognitive functioning. Eventually, however, Gage's health declined, and he traveled to San Francisco to be closer to his family in 1859. 1 year later, he died of a seizure. Phineas Gage's story is important for numerous reasons. First, some people say it was the birth of neuroscience. Since Phineas survived the iron rod going through his cranium and piercing his frontal lobe, it gave researchers insight into how different parts of the brain control different functions of the mind. For example, Phineas's frontal lobe was damaged, but he was still human. He could still do all the things he could do before, but his decision-making skills and personality changed. Researchers could then deduce the types of cognitive processes that occur in the frontal lobe from that information. Second, it shows the importance of these case studies in neuroscience and psychology. Since it is very unethical to pick at someone's brain, let alone damage it, researchers find these types of accidents helpful in investigating how the brain works. Lastly, it shows us the need to produce accurate data. There is surprisingly little left about the specifics of Phineas's behavior before his injury, and it is unclear exactly if his personality changed all that much. Furthermore, more data would have been useful in analyzing Gage's condition as years passed to further investigate the theory that his brain healed. Due to the vagueness of the data surrounding Phineas, his tale is often embellished or oversimplified. Overall, the story of Phineas Gage is very important in cognitive science.
Okay, very good. So, question?
No, I've heard something similar like this.
Uh-huh.
I saw it was like kind of like a documentary where there was this a high school student, really poor student, didn't enjoy math at all.
Sorry, is it gonna be a long
Yeah,
share?
this guy wasn't good at math, all that, and then he had an accident, smashed his head really hard,
Mhm.
that caused brain damage, and then he went, understood math like to a level of like over normal, and
Mhm.
like figured out some like new theories and stuff like that. That just reminded me of this.
Okay. Yeah, so those are rare cases, and we cannot really replicate them, right? If we want to be ethical. And we're gonna talk about brain functions and how different areas of the brain affect our behavior, our personality, in next chapter, I think. So, any questions on case studies? We good? All right. And then we have surveys. Those are a questionnaire or interviews given to many people. The strength is that you can get a lot of data very fast, and they're relatively inexpensive compared to other methods. Limitations, I don't know if we have enough time, so I'll just go over that. So limitation is that the question wording can influence how people answer. And then they can have response bias. Again, people can lie about what they really think if it's related to private information or like drug use associated with stigmatism. People might lie in the response. Social desirability bias, they want to present themselves as a better person than they really are. So those are the limitations. Questions? Do you understand the limitations? Question wording, do you understand that one too? Okay, yeah. Okay, good. All right. Next we have correlational research. They examine the relationship between variables and they answer 2 questions. First, is one variable related to another variable? And the second question is, how strong is that relationship? You guys know correlation studies, right? Or no? No? Yes?
No.
No? No? No response? If you know correlation studies, raise your hands. Okay, if you don't know correlational studies, raise your hands. Okay, so I might need to spend a little bit more time on this then. Okay. But you understand this, right? So we're studying the relationship between one variable and the other variable. You understand that, right? Okay, good. So some important terms before we understand correlational studies. So population and sample. Population is the entire group a researcher is interested in. It can be human beings in general, it can be adolescents, it can be college students, it can be just our class. Those could be populations. So it depends on what the researchers are interested in. And then samples, there are subsets of population studied in a research project, and they represent that population. So I'm going to give you one example. If I'm studying the average height of this classroom, that's what I'm interested in. The population will be the students in this classroom, right? And then a sample will be, I'll take 5 students randomly, and then I get that average height. That will be the sample of the population. Does that make sense? Yes? Okay, good. Okay, practice question. I want to calculate the average height in our classroom. Is the classroom a sample or a population?
Population.
Population? Do you guys agree? Okay, very good. So population. I want to know the average height of the United States. So I use the average height of our class to predict the average height in the United States. So our classroom now is a sample or a population?
Sample.
Very good, very good. Okay, so correlational studies. First, we have R. That's what we call correlation coefficient. And then we have either plus or negative signs that indicates the direction of a relationship. So it's either a positive relationship or a negative relationship. And then this indicates the strength of the relationship. We have between -1 to +1. When it's close to 0, it means the relationship is weak. When it's close to either -1 or +1, it means that the correlation is strong. Does that make sense? Okay. We have about 2 minutes. I'm going to give you some examples. So positive correlations. That's when we increase one variable, it will also increases the other variable. For example, the hours spent studying and the grades on your first exam, they should be positively correlated, right? The more you study, the more hours you spent, a better grades you should get. Hopefully, right? Okay? And then negative correlation, that's when you increase one variable, it will decrease the other variable. An example would be the number of classes you missed and the grade on your first exam. So the more classes you missed, the lower the grades you will get. That would be a negative correlation. That makes sense?
Yep.
All right, and then we have zero correlations. That's when you have no predictive values. So the number of classes you missed and the number of kangaroos in Australia. That should be a zero correlation. Okay, so we don't have time to play this game, but when you go home, download the PowerPoint slides, play this game. It helps you prepare for the exam questions. So you click new game, and then you take a guess what this correlation is. All right, we're out of time, but if you want to take a guess what this is.
Positive.
0.7.
Positive point what? 0.7? You say 0.7?
Yeah.
All right. And then, correct. So the true value is 0.74. And then I think you can play again. Well, you know the drill. Just go do this. It's a good practice. All right, that's it. We'll finish the rest on Friday.